Today is Saturday, the 11th of February, a little after 2. The moon is approaching the third quarter, so we won't have any issues tonight. I want you to see this sky. I have not yet to, oh, I see a slight cloud over the top. Oh no, that is a jet trail. Now one of the things I look for in preparation for being able to do some decent astronomy is whether or not jet trails, which I can't quite see in the screen here, but I can see with my eye, are extended and diffuse or not. I have seen them actually cover the entire sky. The other thing I look for, if I'm going to have a good viewing night, is what's going on over Canyon Mountain. Because if it gets a lot of evaporation and the humidity rises to 100%, it'll form clouds. And when those clouds start to form, I know the atmosphere is at high humidity, which means as it cools during the course of the day, what's going to happen is it's going to create a vapor in the atmosphere that's going to make any decent imaging impossible. Not so much for stars. Globular clusters are okay, open clusters, but for galaxies and nebula, they get lost in the background lack of contrast. So I wanted to lay out the plan for tonight. This is probably the best time, that and last night, which got botched because of vaporization of the atmosphere, to see the green comet. So that's the main goal tonight. And then I'm also going to take a look at some galaxies and clusters and nebulae, mostly in Orion and Lepus, and hopefully M1 will give us a good view in Taurus. Well, what I wanted to do was just lay out, this is the kind of conditions I expect to see if I'm going to get a decent night out. But later on in the afternoon or early evening, if the clouds start forming, there's another good sign there. There's no extended trail on that yet. Then, if clouds do not start forming, we should have a good night of deep sky and green comets. It's now 4:15 the same day, and I'm beginning to see suspicious signs that the sky is going to deteriorate. There are clouds, if you can see them now, forming over the northwestern hills. And I noticed this same phenomena yesterday, despite the fact that yesterday the sky was equally as clear and brilliant as it is now. What I'm going to do is walk up to the observatory and point up at the sky for a reference point, and then I can use it as a comparison. Notice there's quite the blue. It's not a pure blue to my eye. It looks better in the camera, but there are signs of water vapor, and if we turn to Canyon Mountain in the distance, we see that we're not forming clouds there yet. So yesterday I'm not sure that I saw them, so whether I saw them or not, so that's not a telltale sign. Alright, well, we're going to wait till sunset for our next review of atmospheric conditions, because frankly I've been getting very poor results, as mentioned earlier, in terms of galaxy and nebulae with the Rev 2 imager. And I'm ascribing it primarily to a haze. Oh! Here's something of significance. I don't know if you can see it. There's no chemtrail on that jet. So that indicates the humidity must be lower because the vapor isn't condensing and then distributing itself across the sky. That's a positive sign. All right, till later. It's now 5:15. You can see the sun is, if not set, it's well to the south and to the west. Looking at the sky, you can see that there is water vapor up there. I don't expect it to get dark until 7. And if all goes well and the night sky cooperates as well as the Earth's atmosphere, might get a look at the green comet. And there's the view, the last sun falling on the flanks, the western flanks of Canyon Mountain. Okay, it's 7:09. We've had a look at what should be a green comet in both scopes. We have an ST-80 out for an eyepiece view, and we have the Rev 2 imager on the 6-inch. Now, you can see this right there. It's pretty bright, but I've got it in color mode right now. But all I'm seeing is a bit of purple, so we're not really getting a real green sense. But this is Comet 2022C, otherwise known as the Green Comet. I'm using my maximum settings to get the greatest amount of brilliance. The sky is not particularly clear, but it's a little bit of haze, but it's better than it's been. I did get a particularly good view of M1, so I'm not confident we're getting as much view that we might want. Anyway, so what we got here is we have the head of the Green Comet. It has a 50,000 year orbital cycle. It's already past perihelion, which is as close to the sun as it was going to get. I think it's now streaming away. It's in the region of Mars, and I tracked it down. I'd say it's south and east of Mars. I could be wrong. It could be south and west, but I think it's south and east. We're getting a pretty good view. As I said, a lack of color. Now this comet is extremely eccentric. When it gets to aphelion, which is as far away as it's going to get from the sun, it's going to be some 200, I think it's going to be some 2,000 astronomical units way out. And in doing some research on this, I learned that it's going to go out past, the Oort cloud is out past what is called the heliopause, which effectively means there's a region of space where the radiation pressure from the sun in terms of light and ionized particles is less than that of the galaxy itself. Now Voyager 1 and Voyager 2 already exited this region of the heliopause some 20 years ago. But here's our view of what is called the Green Comet. Wow. And it wasn't easy to find, even in the finder scope. It was a very faint nebulosity. But here we're seeing it at 256 flood, 42 auto gain control through the 6-inch Skywatcher refractor. All right. Enjoy. The last view of the comet, let me see if I can turn this. Our last view of the comet was in color mode. I put the imager in day mode. It's supposed to be sensitive to color. It didn't really show any of the color, frankly. What I'm doing now is I've shifted the comet to the lower left-hand corner of the screen, hoping that more of the tail will reveal itself. So that's the view we're getting right now. So I'm going to sweep it a few times so you can see if the tail makes itself a little more present. As I mentioned before, this is a once in a 50,000 year view of this comet. It's going to extend itself well out beyond the heliopause. Some 2,000 astronomical units, something like 10 or 20 times the distance to the planet Pluto. So this baby really gets out there. In fact, if we have an encounter with any other massive bodies in space, which is probably what sent this thing reeling into the center of the solar system anyway, this orbit could become what is called hyperbolic, and we would never see the comet again. But right now it's apparently in a parabolic orbit. But if it encounters one of the planets, any kind of weird gravitational influence could just send it hurling out into the deep depths of space in the Milky Way galaxy. So this is the last view we're going to get of this. And I've been working on finding this for quite a while now. I have not had the kind of skies that would reveal it well. We're very fortunate to see it tonight, even though I looked for it last night. All right. Okay. Oh. For the record, we actually got a view of, as well as the comet, Messier 1 tonight. Supernova remnant in Taurus, magnitude 8.4, large, 8 by 4 arc minute, 6,300 light years distant. And here's our view, and you can see the action on the screen of all the ice crystals in the atmosphere and things, but at least the transparency is better tonight. So this is Messier 1. presumably the very first comet that Messier did not discover when he started his tour of the night sky and noticed that things he was finding didn't actually move in the way that he had hoped. Messier 1. I've got a number of other studies I want to turn up tonight. I'll go ahead and we'll go to 42 and 43 just for the heck of it, although we've already imaged it, and see what it's like under these conditions. Now I have maxed out the settings, so it is pretty brilliant, but you can see some really nice texture in the supernova remnant, and it is very frigid out. So I had a stall on the mount and decided that instead of going to M4243, I'd go deep south first. This is a view of, whoop, come to focus. This is a view of Messier 79. It's a globular cluster in Lepus. So I'm going to give you the specs on this once I selected it once again. But you can have a look at it. Hopefully I can hold the camera nicely while also manipulating the controller. No, that didn't work. Let's see. Multitasking. Okay, the data on Messier 79 is, it's a globular cluster in Lepus, magnitude 7.7, fairly bright, large, 7.8 arc minutes, 42,000 light years distant. That is way out there. In fact, it's pretty much in the opposite direction from the core of the galaxy, since this is a wintertime study. I believe Orion and Canis Major are the opposite signs to Sagittarius and Scorpius, so I'm not for sure. Anyway, this is the view we're getting. Once again, to recapitulate. Okay, so this is pretty towards the south. As you know, it's about minus 25 degrees, so it's only about 12 degrees above the horizon. Not a bad look. Brilliant core, condensed, numerous bright stars on the fringe. Probably, as I say, largely they're about 6 magnitudes fainter than the galaxy itself. So those are 13th and 14th magnitude stars that we're seeing there resolved in this beautiful cluster in Lepus. All right. That is the galaxy in Lepus, NGC 1964. A little brighter than the 11th magnitude, 10.8, fairly large, 5.5 by 2.1 arc minutes. Ordinarily, to get a good view of this, you probably need a 12-inch scope at 71 million light years distance. It's also fairly low. And here's the screen, and I'm not sure that there is a galaxy present. I'm at a very awkward angle here. The stars are a little distended, which means the floor's been disturbed, and we're going to have to give it a little chance to stabilize the image that we're seeing on the screen. I'm holding the camera at an awkward angle. I'm hoping you're getting a halfway decent view and that there will be a galaxy present, but I can make no guarantees of that. Maybe what I ought to do is swing to Messier 77. Maybe it will not be blocked by the observatory. We can use it as a nice little test to see what kind of views we're getting. But tonight's the best night I've had in about a month. So hopefully there's a galaxy somewhere on that screen, even though I'm not able to make it out at my current viewing angle. Okay, fortunately the scope is not being obstructed by the observatory roof. M77 is a galaxy in Cetus, magnitude 8.9, a couple magnitudes brighter than the last one. In Lepus, 7.3 by 6.3 arc minutes, 60 million light years distant. And this, even though it's very difficult for me to see, is a clear view of this bright face-on spiral galaxy. Hopefully you'll see the spiral extensions. This guy is supposed to have a long central bar, and you're supposed to be able to see the spiral extensions around it. I believe it's supposed to almost appear circularly, and I can't tell whether or not because I've got my arms extended and I'm in a very awkward position here. So hopefully what we want to see of 77 is on the screen. Why not try for M74 too? Just maybe it'll turn out. M74 was obstructed by the observatory, so I've returned to my culminating studies. NGC 1832 is a galaxy in Lepus. Its magnitude 11.3. It's smaller than the previous one, which I believe was 1964. 2.3 by 1.5 arc minutes. It's a barred spiral with a ring, 85 million light years distant. And I can see it on the screen. It's fairly small, located right there near the center, so the alignment's pretty good tonight. That's our view, and it does have a bit of a ring about it. So happily, we're getting a pretty decent night sky. Yeah, I can see the ring even from my off angle here. So let's see if I can position it just right. So you get the optimal view right there on the border of the dark bar on the screen. Yes, indeed. So we are seeing galaxies tonight. Some of the icing and haze is being eliminated. The sky definitely looks darker to my eye. Okay, let's make this an official view of Messier 42, a nebula in Orion, magnitude 4.0, 90 by 60 arc minutes, which means 3 times 2 times the size of the moon or sun. 1600 light years distant, star-forming region in the minor Orion spiral arm of the Milky Way galaxy. And you can see the luminosity is simply overwhelming tonight with this clearer sky with less light absorption going on. Need to give it a little time. You can notice the stars are a little oblate, which means we got to give it a chance. So what I'm going to basically say is I have other views of it. I'm going to run out of battery power soon. It's cold out. But here's the view I am now getting through these more transparent skies of this night that reveal the comet as well as some of the galaxies in Lepus. So it shows you what a difference transparency makes. Our next study is NGC 1973, another nebular region in Orion, magnitude 7, 5 by 5 arc minutes. 1600 light years distant, so it's in the same basic region of star formation. And you can see the nebulosity forming on the screen. I had a look at this just last night and I could barely see any nebulosity, so the transparency is quite a bit better. So here's a little sweep. Unfortunately, I cannot, especially at this angle, get a very good view, high contrast view without sweeping the camera over the image. And I'll have to invest in some other equipment in the future if I want to get a good flat image that can display all of the study's features across the screen. The problem is particularly bad when I'm sitting here with the scope doing its equatorial flip to the west for some reason, I've noticed. That's about it right there. I'm going to go on to NGC 1975. It shouldn't be much of a jump. Here we are now. Here's the spec on 1975, Nebula Orion. Magnitude 7, larger, 10 by 5 arc minutes, 1600 light years distant. Very close to the celestial equator. We can assume that 75 is a nebulosity towards the center of the screen, mostly centered around this very bright star, progenitor star here. So here we go. Our next study is NGC 1977, Nebula Open Cluster in Orion. Fairly large, 20 by 10 arc minutes, magnitude 7, 1600 light years distant, all in that beautiful star formation region Now what's interesting about this is we have another very dark region right here where the cold dark matter is yet to precipitate into stellar material and yet to be excited by the radiation from this bright progenitor star. I would assume this dark nebular region obviously is closer than 1600 light years. But here's a very good look at it. NGC 1977 in Orion. Very close now. We're getting towards the belt of Orion. Last NGC for the night is NGC 1981 Nebula plus an open cluster in Orion, magnitude 4.2. Is almost as large as the Moon, 25 arc minutes, got about 20 stars, the brightest is magnitude 6.3, and it is closer than the star-forming regions we've already been viewing at 1300 light years. Nebulosity is fairly faint. The cluster is very bright. In fact, it's so large that nebulosity pretty much extends throughout the screen and is very difficult to resolve it anyway because it doesn't have any frontier. But it does appear that nebulosity is present. Okay, our last new study for tonight is taking form on the screen. You can see two eyes of a bright star right there on the boundary, two bright stars and nebulosity around this. This is a Messier 78. The nebulosity is relatively faint. I have seen it through a 6-inch telescope and it's pretty clear that I called it the Casper the Friendly Ghost Nebula. So the nebulosity is clear. It's obvious here. This image hasn't fully formed yet. And it certainly is brighter than it appears to the eyepiece, even on a good night. It appears there's other nebulosity also present on the screen associated with this region. Once again, another star-forming region in Orion. And let's see. Did I capture the data on it? No, I didn't. Well, let's go back and do that. As the image is forming on the screen, Messier 78, nebula in Orion, magnitude 8.0, 8.6 arc minutes, and it is at the fabled 1600 light years distant star-forming region that's associated with M42, 43, and the NGCs, 73, 5, and I believe it was 7. And here's our view. And you'll notice there's plenty of nebulosity present now after the image has had a chance to form well outside. Here's the two eyes of the progenitor stars, I believe, in the cluster. There is some faint detail visible inside the nebulation. There's nebulation around this bright star as well, plus more distant nebulation. So there's probably quite a few areas of nebulation on the screen. I am actually seeing them as I swipe the image back and forth using the handheld camera. So, Messier 78, star-forming region in Orion. Well, I thought we'd carpe knocked him out on this view of Messier 1, the supernova remnant in Taurus. There we go. The night sky has only improved as it's progressed. Usually the seeing transparency gets worse. On this particular night, it has indeed improved. I believe it's around 8:30 in the evening. I am done with my observation tonight. We started off with a decent but not green view of Comet 2022-3, and here is a fine view of Messier 1, supernova remnant in Taurus. Carpe Noctem. Since we're having such a very fine night of observing, I thought we'd take a look at Messier 1 at the lower 64 flood. sensitivity rating. We're not seeing as brilliant a nebulosity, but the stars certainly are more attractive and the image is being generated quicker. So let's do 42 and 43 using these lower exposure times because it was certainly being overwhelmed earlier at 256 flood. So there's M1. And that view of M42 and 43, right there at 64 flood. It's still a bit overpowering, isn't it? But much, much more fine detail and texture visible now that the core of the nebulation isn't overpowering the screen. Very beautiful. SVA 42 and 43. Perhaps the next good night out I'll get the designation for the Horsehead and we'll have a view of it against the backdrop of nebulosity. I believe the Horsehead's a little north of Alnitak in the belt, right on the equatorial of the equator of the sky. There's our view of M42. And seriously, folks, it's pretty cold. Good. Carpe noctem and good